five. Number five. Two position vectors. So I'm looking here for first the RA vector that's 20 degrees below the positive x-axis. So they all have RA vectors that are that. And then I'm looking for an RB vector that has an angle of 54 degrees above the positive x-axis. And they all have that, so that's good. And I'm adding those together, so I'm looking for the ones that have those in a tip-to-tail relationship. Tip-to-tail, and then, so that would be, the ones that would be tip-to-tail would be the upper right corner and the lower right corner. The difference between those is whether my resultant goes from the tail of RA to the tip of RB or reversed. And I remember my rule is tip to tail, then tail to tip. So my arrangement is going to be the bottom left, bottom right corner here. Which is kind of nice because then it's done my ray diagram for me. Guys, remember, if you're working on a different problem, that is completely okay. Just try to be a little bit quieter so that those who are following along can follow along without too many distractions. All right? And now they want to know what is the magnitude and direction of vector RC. Give the angle, during the angle measured counterclockwise from the positive x-axis. So let's see, let me get down some facts here into my diagram. Tell me that this angle is 20 degrees and this length is 54. The second is at 54 degrees. So this angle here, maybe not 50, is at 54 degrees and has a magnitude of 75 meters. In my case, it was the lower left eye. I'm using the one that shows the vectors added tip to tail and the resulting going from the tail of the first to the tip of the second. If those two vectors are in a tip-to-tail relationship, the tail of the second vector is on the tip of the first vector. The tail would be the non-pointy end of the arrow, and the tip would be the pointy end of the arrow. Yes? Okay. All right, so I'm going to figure out the components of each of these. I read them from my problem. Possible, quite possible, yeah. So I'm just going to redraw this to help myself picture it. I got this. Whoops. I've got this, and I'm going to have a horizontal component and a vertical component. This is 20 degrees. The side is 54 meters. I'm just redrawing this by itself. Yeah. And so the adjacent side to the angle is always going to be cosine. So this side is 54 meters cosine 20 degrees. The opposite side is sine. So this is going to be 54 meters sine 20 degrees. Right? So I've broken those two components. Broken RA down into its components. RB goes this way. Where this is 54 degrees and this is 75 meters. So the adjacent side again is 75 meters cosine 54 degrees. From my problem again. It said we all have 75 for the length of the second vector. And then opposite side will be my 75 meters sine 54 degrees. If I draw these up here, just kind of sketch them in. Do you see how, well, it's the best one. Let me redraw it. The way I now see it is I've got my vector C goes in this direction, right? The addition of those two, right? My vector C, this is C. I've just redrawn it, okay? If I add up the components, they add up to the whole. So if I look at my two x components here, if I take my green one, because they're both pointing in the x direction, x, y, z, and I add to that one x component, I add to the other one, they're going to add up to the x component of my vector here, my overall. And now, here's the only problem. This one goes down, right? Remember, to add vectors, I still have to be tip to tail. So that one goes down like this. And then the blue one comes back up to form that side. Notice they're all arranged tip to tail, right? I will post it, but if you ask me, I can print it out also. Well, remind me. So, mathematically, what I'm going to do here, I'm going to take this value for I want to figure out this component. That's going to be 54 meters cosine 20 degrees plus 75 meters cosine 54 degrees. Because those two add together to be that one. Oops. And then for my vertical here, that's going to be 75 meters sine 54 degrees minus 54 meters sine 20 degrees, because it's pointing downwards, so it's mathematically it's negative. That's why I'm suddenly hot. You guys stole my thing. Okay. So I'm gonna figure out those values. You figure out your values. So let's see. Make sure you're in rating and you're in degrees. For my green one here, I get 94.8272954. And for my blue one, I get 42.20718684. I'm getting close. I'm almost done. Now I have two legs, and I want to find this length, RC, and this angle. So to find the hypotenuse of a right triangle, when I have the two legs, I'm going to use Pythagoras, right? So to find the length of this, I'm going to use a squared plus b squared equals c squared. That's what they want, right? The length and direction. Yeah, they want magnitude and direction. So I'm going to figure out the magnitude by 94.827 squared plus 42.207 squared equals RC squared. So it's the length of RC. Yep. Well, C is the magnitude. Well, no, that's the most common mistake on a problem like this. You forget to take the square root. So I get 104. Is it meters? Is this all in meters? Meters. Let's see if I'm right. We're going on. Direction I'm going to use tan to do. Comments this. Okay. And now, so I got the magnitude right, so I'm on the right track. And now I need to figure out theta. Well, I know the opposite side and I know the adjacent side. So I'm going to use toe. Actually, I know all three sides, so I could use any of them, right? I'm going to use toe just because I have it. And I don't like tangent to feel unloved. So I'm going to do tan of theta equals opposite. That's that 42.207 meters over adjacent, which is my 94.827 meters. Now, I have the full numbers in my calculator, right? I'm just not bothering to write them all out. But I have them saved in here, so I don't have to worry about rounding. I know. No. Because I have tan theta equals that. So I need to get theta out of there, so I'm going to do the arctan of both sides. And that leaves me with theta equals the arctan of 42.207 meters over 94.827 meters. And that gives me an answer of shift tan on most calculators will be your arctan. Like mine is second, the blue second key. So I have a TI. And I get 24.0 degrees for mine. Yay! I got it all.